Hello, hi, my name is Don Shin, and I'm a product marketing manager here at ixia. Thanks for joining this webinar. In this session, we're going to discuss some interesting ways that you can garner a lot more information about how new security technologies will perform in your network. Things that you really need to know that go way beyond what a data sheet is able to tell you. There is enormous pressure to ensure security and network resiliency. The price of being wrong, even once, is steep, both for you and your business. In these times of rapidly changing threat landscape, adopting new technology is important and to a certain degree inevitable. Recently, I was reading through a report from Infonetics, and it was discussing how IT departments are finding it difficult to adopt new security technologies in spite of the fact that they know that it's a necessary task to be done. And as I was reading through the report, what I interpreted from it was that decision making was being stalled as a result of a lack of information. And what really IT managers trying to get to is to really understand how this technology will impact their security. This is both from a functionality perspective, understanding cost and how to optimize those investments around right sizing, choosing the right vendor, choosing the right kinds of technologies, understanding performance, and really sort of a holistic view of the specifics on, rather than the general sense of what does the technology do and what data sheets offer or the promises from the marketing departments, but really how it's going to behave inside of their own network. And as a result of that, it makes decision making slow. So if we sort of step back and consider, how do you make decisions on security technology deployment? If you're like most, what usually the process is reading through data sheets, possibly getting a unit from the vendor, bringing it in a house, navigating through the GUI, looking at the specific feature sets that you're interested in, but not really being able to test it in a realistic enough environment. Then other tasks that you may do is to read through third-party reports. There's a number of quadrant reports that are out there that the analysts are doing surveys and questionnaires to users and coming up with an interpretation. And then lastly, you use your trusted reseller network that have experience with other customers, as well as have been a good resource for you in the past. But once again, a lot of this information is really anecdotal and doesn't really answer the question that you need to get to, which is, how is this technology going to behave in my environment, my unique environment, and what's the impact to security? So if we sort of step back to data sheets and just take a single dimension like performance and try to understand what is it that the data sheet is telling us and what's the relevance of it. The traditional ways that data sheets express performance are following two standards. One is the RFC 2544, which was developed back in 1999, and it uses UDP traffic with synthetic payload sizes, small packets, large packets, and it was developed really for switching technology, right? So it's really a layer 2, layer 3 kind of functionality, and it has no value for content-aware devices like modern technologies, specifically modern security technologies. An alternative that's being used more and more often is the RFC 3511. And RFC 3511, once again, was developed a number of years ago, and it uses HTTP as a transport. You specify object sizes, and it gives you benchmark performance primarily for stateful firewalls. But once again, is these object sizes synthetic, and your network doesn't have these kinds of packet structures inside of it, and it gives you a false sense of security, because HTTP is really a transport nowadays. Because after all, in our modern networks, it's really applications that drive businesses, and it's applications that you care about. So when we look at sort of averaging of what kinds of traffics are on enterprise networks, you can garner sort of the complexities that are really out there, and those types of specs really don't give a good view of how they'll behave inside of these particular networks. But especially we need to also recognize that your environment is not an average environment. Your environment is unique. It's unique, and that there's no two networks that are the same, and the usage behaviors in the networks are very, very different. So one consideration is rather than the traditional way, what if you could model your entire environment, create a test to be able to run a proof of concept or do device evaluations, and have the fidelity of being able to model all the way down to a single user and at a scale that's relevant to your particular enterprise. And then on top of that, be able to model security threats such as DOS attacks, such as exploits, and do that in a reproducible and a scalable manner to be able to accurately understand how these technologies would work in your particular environment. So I think the first thing we'll do is we'll take a look at a true case study. So this was a large bank that had asked ixia to come in with our breaking point platforms, our testing tools, to help them to do a proof of concept or POC as they were moving from stateful firewalls to next generation firewalls, which today is common, and I'm sure you've either done this or you're in the process, or very soon you will be adopting next generation firewalls. They had a few other criteria. One was that they wanted to narrow down to a single vendor, which is sort of obvious that from a manageability perspective wise. And then also they recognized that they had 4 distinct use cases inside of their environment. And so one of the first things that we did was we worked with them to model network traffic that would model those 4 distinct areas. And you can see in the graph here the differences between the areas that they were wanting to defend with next generation firewalls. So with ixia, they had narrowed down to 3 vendors, which is pretty common when any enterprise is going to evaluate new technologies, right? And all 3 of the vendors advertised their next generation firewalls as at least 10 gigabit per second next generation firewalls. So the first thing that we did was we started a baseline test, and you can see in this graph here on the left, by using RFC 3511, what we see is that really no information was garnered beyond what the datasheet would have said. In this particular instance, this test, none of these 3 actually reached that 10 gig, but nonetheless, by using synthetic traffic loads, really nothing was really established. But then, by applying the real traffic, or the models of the real traffic that showed real-world applications and security threats into that traffic mix, now you can see quite a bit of difference in the behavior of these next generation firewalls. It highlights the biases and the engineering things that they were trying to accomplish with all of these, right? Interestingly, the sort of a conclusion on this particular POC was that the incumbent vendor of the next generation firewalls was not the one that was selected, and using quantifiable data became the means of being able to justify this and sort of rationalize why they were moving away from this particular vendor. And interesting also is that this particular POC took 3 days to get to quantifiable data, which is I think for yourself you should consider how fast do you make decisions, how quickly are you able to reduce the attack surface by adopting new technologies, right? And so this sort of brings us to what is this all about with POCs, and it's the sometimes in IT organizations it's a 4-letter word called test, right? And test sometimes gets linked with other four-letter words like cost and time. But we consider what we read in the media and even sort of firsthand experiences that we've had of there's a long list of companies and organizations that have crumbled as a result of very bad practices and not being able to test their security well or the capacity of their particular networks. Intuitively as engineers, we know that testing is an important and vital element of validating network design, ensuring security, and then also in testing for change control, right? Whenever there's a significant change happening on the network inside the applications, because testing inherently builds more stable networks that are higher performance, that are resilient, and most importantly, helps to prevent surprises from happening. So what are some of the reasons that I hear from IT managers about why don't they test, right? One is it's expensive, right? And yeah, there's definitely expense associated, but you sort of it's that the traditional saying of if doing the right thing usually will save money in the long run, right? And another one is vendors test, so I don't have to. But we need to also recognize that what the vendors are testing and why they're doing it has very different objectives than what you would do as an enterprise, and as the use case illustrated, there's really a lot of information to be garnered off of it. And then lastly, a lot of companies just don't know that they have the capacity or how to do this, and that there's tools out there, modern tools out there, that is able to reproduce reasonably accurately your enterprise network for both legitimate and illegitimate traffic. So maybe inside a part of testing also is that there's traditional ways are complex, right? Most organizations, when they do testing, go in the do-it-yourself lab configurations where they're cobbling together synthetic traffic using open source tools. They are usually building one-off tests, so reproducibility becomes really a problem. Scale becomes a real problem because you just can't create enough VMs to model their entire network. And also, most of these types of scenarios don't have the capabilities to doing security testing or creating malformed packets in order to see how resilient it is against fuzzing. And that's what ixia, in particular with a product that we have that's called Breaking Point, that can run on our PerfectStorm platform that I'll explain a little bit more about, is able to do. It can create enterprise and even nation scale of application traffic. It's a whole ecosystem in order to produce that reproducibility, and then comes with all of the underlying engineering that ixia provides, both from traffic and usage and reporting. So here's another case study. At RSA, we had a guest speaker from United Healthcare come, and they were giving a speech about the impact of proof of concepts when they were moving to next generation firewalls. And so there was quite a few interesting insights inside of it. I'll just point to a couple, but you're welcome to come to our blogs.ixiacom.com and read the highlights of it as well as watch the video of the speech. But one was the insights that they garnered off of it was that, although they were subscribing to analyst and industry reports, devices that had fared poorly and received poor marks in their particular environment ended up outperforming other devices. And so, that uniqueness of the network becomes really important as, analyst reports and third-party labs can depict a environment, but not every environment. They also had issues with vendor bias, whether it was from an incumbent vendor, which is very hard to overcome legacy, or if there was somebody inside the organization that had read about an innovative new technology, sort of defending what was the right choice and coming to the best conclusion for that organization really should be data-driven, and by conducting a data-driven POC, they are able to get to that point. Now, and then the fifth point here also that we need to also consider is that, we said testing sometimes considered cost, but really the investments that are happening on large data centers are so significant that having data really helped them to improve the discounts as well as right-sizing their security with the appropriate performance levels rather than derating off of some arbitrary value, right? And so there was a lot of financial benefits associated with them for doing this POC and conducting these kind of tests themselves. So earlier I mentioned about the platform or breaking point, and back in October of 2013 we had introduced a platform, a really groundbreaking platform called PerfectStorm. And PerfectStorm was a bladed chassis that expanded all the way to 960 gigabits per second, so nearly a terabit of application traffic, supporting 720 million concurrent sessions at a rate of 24 million new sessions per second. And with our industry-leading IX load and breaking point software, basically it was able to test pretty much almost all the elements of the modern network. This includes voice, video, data, complex storage workloads, being able to test the variety of network applications and devices like load balancers, security products, even able to test elements of the mobile network like 3G, 4G, LTE, and then of course just as importantly is security. A couple of months ago we introduced a new platform that's called PerfectStorm ONE that was targeted towards enterprises, in particular, making it much smaller and the business model matching up closer to what enterprise IT managers would need. And we market this product as PerfectStorm ONE POC in a box. Right? It's a small, somewhat portable device, less than 2U in height, and I think it's 13 inches wide. But the really remarkable performance, when it's in the fully loaded configurations, it supports 80 gigabits per second of application traffic, 60 million concurrent sessions, 2 million new sessions per second. So, really quite large enterprise scale. Has hardware acceleration for SSL and IPsec, and then, as I mentioned earlier, the support for voice and video as well. It is sold in a license model that we call buy only what you need. You can start with a 4 gig by 1 configuration, and then through licensing upgrade that all the way up to 8 times 10 gigabit Ethernet. So scale to match as your needs grow for testing. But the real magic inside of the breaking point is the software, and in particular the application threat intelligence, which is a subscription model to our breaking point platform that includes both real world applications. So there's over 250 today. There's actually closer to 300 of these protocols that are supported, applications that are supported. We have over 3,000 pre-built superflows, and a superflow is the behavior of a single user doing things like social media, running a SIP call, browsing the web, running an enterprise application like a database, playing a game, and then in addition to the real world applications, it also supports security. So we have over 6,000 security attacks built into it, and over 35,000 pieces of live malware. What you would use with that malware is to be able to detect intrusion as well as model botnets for doing DOS attacks. And then the security attacks themselves, we have over 180 different evasion parameters that you can put on to the attack so that it really much more accurately models what's happening in the wild. And the ATI program is updated every 2 weeks so that you can stay current with the modern applications as well as the security attacks that are out there. So by using Breaking Point and PerfectStorm, what you are able to do is to create a test environment where you put legitimate traffic and malicious traffic into that network. Right? Over on the left side, what we're showing is a diagram of what we internally refer to as a two-arm test, where Breaking Point is modeling both the clients, the legitimate and malicious users on the network, and then also is able to model the servers so that you have a sort of closed loop test in order to be able to extract all of the test results off of it. But in addition to being able to run these two-arm tests, Breaking Point can also be run in what we call one-arm mode, where we would model that those users and the malicious attackers onto that network and terminate this sessions to a real server that's inside of the network. Okay, so let me show you a very quick demo. Okay, so here we're at the Breaking Point homepage, and I'm going to open up a test that I had previously built. Let me zoom this up a little bit for you. Right. So this is the main control panel that you'll use to build a test. And we have a number of test components over here that you are able to call up. We have the application simulator, which is the tool that I mentioned where we're going to build legitimate users or applications on, and then as well as you can application layer kinds of malicious behavior as well. And the two components that we're going to focus on, the three, is that we have this routing robot which utilizes the FPGAs inside of the inside of our system to create really high rates of attacks or traffic loads. And then lastly, we're going to look at these security components. So if we look at this application builder or application simulator, what I have is two parameters specified. One, I've put a malicious user that is creating an attack using slow loris in particular, and then I have this other one that's called the valid users or valid workload. And if I look at the valid workload, I have at the beginning we're specifying parameters on performance and whatnot. So here I've specified 6 gig of traffic with a maximum number of sessions that can be initiated and at what rate. And then lastly, I have specified what's called here is this Breaking Point 2003 mobile profile. Right? So these app profiles are pre-built libraries that you can import into your test. Let me show you this. Okay, and but you can modify this to your particular network. Okay, and this is where I mentioned before that we have with all the application protocols and so forth. So if I open up the mobile 2013 here, what we can see is that this particular application profile is built using Flash video, Netflix traffic on here, YouTube traffic, Facebook, and Pandora, and here we specified the percentages that we want to have of these particular traffic mixes. And if we look at any one of these, like let's look at this YouTube here, and YouTube here, and what this is calling is one of the superflows that I had mentioned earlier, of that over 3,000 different kinds of superflows that are here. And this particular superflow, you can see that looks like it's an iPhone doing this particular access, and it's starting a TLS session, logging in, retrieving a video, and then finally closing out the session. Right. And so here we could save this off and modify all of these parameters, add additional superflows into this particular mix of traffic, so that you can get a more accurate representation of your model. And there's a pretty large library of these. The other manager tool I wanted to show you also was that I had mentioned that we can put the security attacks inside of here. And so in this strike list here, you can see there's over 35,000 of these in this particular version of this, and so we can search for things like Microsoft vulnerabilities. We see that there's 1,514 of those, and then specify the CVE that is referenced for that particular vulnerability. But we can build a library of security elements now that we can embed into that same test, as we did here. Let me open this test again. And here we have the security, and we built what we call strike level 1, which would be the critical security as reported by a variety of CVEs and repositories. Some other things to look at here in this test is that we have 131,000 unique IP addresses that are being run in this test. We have 12 superflows and 183 security strikes that we're going to run. The way that this test was built was that as right now Breaking Point is initializing all of the hardware and getting ready for the test. In this particular, we have a cable that's looping back across two 10 gig ports, so this won't be a very good firewall, but nonetheless I think you'll get the general sense of it. But the test is built on using that legitimate traffic of 6 gigabits per second for the first 30 seconds, and then 30 seconds into the test we're going to layer an additional UDP DOS flood on top of that test, and then 1 minute into the test, and we're going to start to send the strike level 1 attacks that we had specified. And so the model of this would be if you were doing a proof of concept on a DDoS appliance or a firewall, you really want to keep an eye on what's happening to the legitimate traffic, because blocking an attacker is important, but just as important, especially like in a DOS attack, is that what's happening to the legitimate traffic. And so you really want to be able to keep an eye on that, and then having the security attacks with legitimate traffic with DDoS, and to understand what does this appliance do in that stressful kind of an environment. So here we see that we have about 6 gigabits per second of traffic coming across here. Here's a timeline. We're at 18 seconds, right? And we can look at the application traffic mix that is being used at this particular time, and there's Pandora, Google Play, so forth. Now we've just crossed the 30-second mark, and now we see that the bandwidth has gone up to 9 gigabits per second, which is that we have that 3 gig of DDoS attack or the UDP flood that's happening in this particular test. Right. So going back to the application traffic mix here, where you can see what is the distribution of this particular workload. And then lastly, we had specified that at 1 minute that we're going to start to add the security attacks inside of it. And so here we've got there have been 68. You see this incrementing that were sent, and of course this loopback cable is not very good at being able to defend against an attacker, but it's an illustration of how this test is done. Okay, and then resultantly the test will conclude and come back with a result, and then we can go to the reports and go really understand the details of what happened on each of the superflows, what kind of latencies were there, all of these parametrics to really understand the results of the test. Okay, so let me come back to this. Okay, so now some other examples of things I mentioned that, in that demonstration we were talking about DDoS, and DDoS is such an important consideration for IT managers today. The impacts are really staggering, especially the numbers wise, as the attacks are growing in size, they're growing in frequency, and the impacts to companies are really growing. The other interesting statistic is that if you look at the reports, DDoS mitigation is the fastest growing segment of the security market. So, an important consideration is if you haven't already made your investment in on-premises gear as well as scrubbing services, you're probably going to be making them soon. So you would want a methodology in order to be able to ensure that you're maximizing your investments. So another case study was a service provider that was starting to introduce upstream DDoS scrubbing services, right? And so they were wanting to conduct a POC for what was the technology that they wanted to adopt. And so in this particular instance, what they had outlined the types of attacks that they wanted to be able to defend against. They brought in the 3 vendors, and then from here they were able to capture the parameters of did it block it, these NDs are not detected, and then how long was it before the mitigation was able to send an alert that something was happening. So really powerful data for making these kinds of decisions. One last case study I'd like to point out is that was a large financial organization. They were contracting an upstream DDoS scrubbing service and spending quite large amounts of in the hundreds of thousands of dollars per month for these services. And what they needed to understand was, one was, did it work, and what happens to the legitimate traffic, and then also they wanted to test their playbook to see, because DDoS is people intensive, especially when you're talking about upstream scrubbing. So we brought our breaking point application onto their premises, started sending legitimate traffic. Then the DOS attack started, and it was really growing from just a gig, and then started to decline. But what happened was that immediately the DOS scrubbing service detected it, but the problem was that they ended up blocking all of the traffic, so that it took a number of tuning cycles to get that to work out right. And the other element that they found was that as the playbook of who contacted who, the response time was just way too long. There was longer than 30 minutes, and for trading kinds of environments, that's quite catastrophic. And so by testing their network on a maintenance cycle, particularly these were done on Saturdays, they were able to garner a lot of information and tune their process to against DDoS attacks. So these POCs become really powerful tools for you to be able to use in order to maximize your investments. Really understanding how it will behave in your environment. Use that data so that you can make your decisions on which technologies to adopt. What is the right sizing of it? What's the right technology? What is the right vendor for that particular one? And you can see here, it's really a broad category of these. Once you're able to model your particular unique environment, there's just very powerful information that you can use. I hope you found the information to be helpful, and so let us know how we can help. Want to try an on-site evaluation of Breaking Point for your next POC? Or we also have professional services inside of ixia that can also assist you with your next POC.